Hi, and welcome to this video for PROG1198 Client Server Solutions. In today's video, we're going to be talking about table-valued functions. This is the second in a series of videos about user-defined functions. So if you haven't seen the one before this about scalar functions, I suggest you watch that one first for a little bit of background about user-defined functions and how they're created. So let's move on. So as I mentioned previously, we have two different types of user-defined functions that we're looking at. The first is scalar-valued functions, which return one single scalar value, and the second is table-valued functions. And these valued functions return an entire table worth of data, so rows and columns populated just like a table, and we're going to be using the word table as a data type. Typically, we use table-valued functions in the from clause of a select statement. So, a table-valued function can be referenced in the from clause of a select statement as if it were a table. This is the main thing that differentiates it from a stored procedure. So next week when we take a look at stored procedures, you'll see a lot of similarities between procedures that produce a data set and table-valued functions. But the difference is that a stored procedure cannot be queried like you can query a table or a view or a table-valued function. So this is a bit of valuable knowledge here about these. There are two different types of table-valued functions that we can make. The first one is called inline table-valued functions, and then the second one is multi-statement table-valued functions. Both of them have similar output. They both produce a table, but the difference is how we build and populate the table that is returned. So let's look first at inline table-valued function. This is a function that returns a table that is the result of a single select statement. So an inline table-valued function can take the place of a subquery acting like a data set, or it can take the place of a view or a table. It's similar to a view, but it offers a little bit more flexibility than views because in a function, you can use parameters, which means that you can use input parameters to control how the table is created. In a view, you're basically stuck getting the same output every time. Now, obviously, the data inside could vary based on how the data in the actual table changes. But with the function, we're able to influence how the table that is returned is built. So let's take a look at this example. The inline table-valued function here takes a city name as an input parameter. So let's start out by reading the function. You'll notice that the syntax is very similar to the create statements that we did when we were creating scalar functions. So we start off with create function, we give our function a name, and then we have the round brackets that enclose any input parameters that we might want to provide. After that, we have the returns clause, but in a table-valued function, the thing that's getting returned is a table. So we use table here as the data type. Then we have as, and if we had multiple lines of code here, we would have begin and end. But because this is an inline table-valued function, we only have one line of code, a single select statement. So we don't need begin and end. We can simply return the result of this select statement. Notice the round brackets around the select statement to enclose the thing that we are returning. So let's take a closer look at the select statement. We're selecting first name, last name, and city from customer, and we're performing a series of joins here to get from customer to their address. So we can show a list of customers' first and last names, as well as city, and there's a where line here that doesn't show all the customers, just the ones having city matching the input parameter. So by calling this function with different city names, we'll be able to get different result sets. Let's put it into TSQL and see how it works. So this example is using the WeAdventure database. That's one of the standard databases that you can get on Blackboard in the databases section. So I'm going to execute to change over to use that database to start. And before creating the function, I want to test out the select statement. Now the select statement includes a variable here, and we won't be able to give it a value without either passing something in or declaring it somewhere. So when I test the select statement, I'm just going to leave off the where line and execute the select statement without it to make sure that we're able to successfully retrieve a list of customer names and cities. So we can execute that. And we can take a look at some of the different cities that we have here. So this is what our data set that is returned by this function is going to look like. We're going to have first name, last name, and city. When it includes the where line, we're going to provide a city name, and we can test this out just by, say, hard coding a city name just for testing purposes to run the select statement and make sure it gives us what we want. So for different city values, we get different output data sets. So the entire result set is going to be returned as a table whenever we call on this function. So let's execute our create statement to create the function in the database. When we want to test it out, we put it in the from line. So this is different from a scalar function because remember, a scalar function returned one single value. So when we're looking at singular values, we're looking at selecting them in our select line or sometimes in the where line, right? But in this case, we have a whole table being returned. So tables and data sets belong in the from line. Now, in this particular example, we're passing Toronto as the input parameter. So let's get that in here. We're going to select everything from this function given the city name Toronto. Now notice I'm just selecting all right now. Now I don't have to select all. For example, if I figure that maybe city is redundant because it's always the same, maybe I just want to select first name and last name. So we can select from the function results just as if it were a table, because technically it is a table. It's a table that is being returned when we call this function. So let's get some go statements in here for batching. Let's take a look at our next example. This example adds an option called schema binding. The with schema binding clause can be added to a function, and what this does is it binds it to the underlying tables. What it means to bind it to the underlying tables says that you cannot make changes to those tables that would affect the operation of this function. So for example, this function selects the first name column out of customer. If this function is schema bound, it will prevent you from removing or altering the first name column of the customer table because it's part of the function. Same goes for last name and city. All we need to do in order to enforce that schema binding is to add the with schema binding clause after the return statement but before the as, and it mildly affects how you refer to various tables. I'll just highlight it here that if you use schema binding, you have to specify the schema name when referring to any tables or objects in that database. So we add DBO dot in front of the name of any tables. So we can add schema binding to our existing object here by saying with schema binding, and I'm going to make this into an alter. We learned in the previous video that if you want to overwrite an existing function, you can choose alter. Now this is going to cause us an error because I didn't specify the schema in front of the tables. So if you see this error message where it says that you cannot schema bind because the name is invalid. So if you want a schema bind, you have to specify the schema, dbo dot, for all of the tables. So now we'll be able to alter our function. So now that this function is schema bound, if I try to make some changes to that table, for example, let's say I try to remove the first name column from customer table. I'm going to alter table customer, and I want to try to drop the column first name. And we'll see the error message that we get due to the schema binding. It says that our function is dependent on this column, so we can't drop the column. It fails because one or more objects access it. So schema binding is really handy to preserve the functionality of your functions. It prevents you from making changes that would affect your function's operation. So it's a really good thing to do. So if you create a function with the schema binding option, it follows these 4 points. Any database objects that are referenced by the functions cannot be altered or dropped. Any user-defined functions and views that are referenced by this function also are schema bound, so it's a cascading sort of thing. It works only if the function and the objects are all in the same database, and of course you must have reference permission on all of those objects. So that's how to make a inline table valued function. It's pretty similar. It's based on a select statement. A multi-statement table valued function is a little bit more complex because instead of returning a table that is generated by a select statement, it returns a table that is customized and built on the fly using TSQL. So this is a little bit trickier, but it's more highly customizable. So what we do is we provide a definition for the table structure in the returns clause that is similar to a create table statement. We write the code that generates the table, not just the select statement that pulls from something that already exists. Instead, we're specifying every column and its data type, kind of like creating a table on the fly. Then once that's done, we're going to populate our temporary table with a series of one or more insert statements. Now, where the data comes from when making the insert statements is up to us. We can generate it, or we can pull it from various tables or other functions or other views or other locations in our database. So let's take a look at an example. This example on the next page creates a multi-statement table valued function that is going to return one of 2 outcomes depending on the parameter provided. So we're looking at 2 different outcomes here. It's either going to build a table that contains employee last names, or it's going to build a table that contains employees' first and last names. So we're going to create either one type of table or another based on the input parameter. So like I said, it's a little bit more complex, but if we pull it apart piece by piece, it's really not too bad. We start off with create function and the name of the function and any input parameters that we need. Now remember, I said I wanted the function to build the table one of 2 ways. So we're using the input parameter to indicate which way we want to build it, with last names only or with full names. So that's what our name type parameter is used for. You can see that I'm only using it to run the if and else statement. Now the return statement is where we build the table. Now I'm just going to skip back a few steps so that we can take a closer look at the inline table valued function returns statement. All it says is returns table. The table that is returned is generated and predicted by the outcome of whatever select statement we have here. So we don't have to make up what the columns and the data types are going to be. They're all going to be implied by the select statement outcome. So we just say returns table. But in a multi-line table valued function, we have to be more specific. So we're returning a table. We say returns table, but notice that now I've given my table a name, a variable name, actually. So we're returning a variable of type table. And after the word table, we have another set of round brackets indicating the table's structure. And if you squint your eyes a little, it might look something like the table structure in a create statement. So the table that we're creating here has a column named employee ID, data type int, a primary key, not null, and then it has another column named employee name that is a varchar and not null. So we can include foreign keys, we have to include data types, we can include different constraints as well. So anything to create the table structure. And this table structure is going to be referred to by this variable name, fn_employees. Now you can name the variable whatever you like. So the type of table that's going to be returned by this function is always going to have this same structure. Employee ID int, that's the primary key, and employee name varchar 56. Then we move on to as and begin and end, acting as the starting and ending point of the code. Now we're using an if-else statement to determine what data is being inserted into the new table. Remember, the table is stored in this variable, fn employees, and I'm performing an insert statement that inserts into that table, but instead of saying values, I'm providing a select statement. So this is another way that you can perform insert syntax. If you're selecting from one place and inserting that data into another, you can perform an insert via select. So the select statement will execute. It's a very simple select statement, picking the employee ID and the employee last name from the employee table. And it takes those values and inserts them into our fn employees. And it just goes from left to right. So the emp ID becomes employee ID, and the emp last becomes employee name. Now the else branch says if name type equals full, well, our input parameter was supposed to tell us whether we wanted just last names or first and last names. So if we say full, it means the select statement, you can see how that's the only difference. We're still inserting the results of the select statement into our temporary table, but the select statement itself is a little bit different because instead of just the last name, now it's inserting the first and the last name together with a space. So in this case, this piece here becomes our employee name. That. So either way, we have populated our fn employees table. So once we get past this if statement, now presumably we would make some kind of default else to populate it with some empty data, you know, if there's nothing there. Or maybe we might want to throw an error saying that you're not using the function correctly if you're not providing one of these two parameters. Or maybe we can make it so that one of them is the default outcome. If you don't specify, you get just last names, for example. Regardless of what happens, after this point, we can assume that the fn employees table exists, and we're calling return on its own. Notice how I'm not saying return at fn employees. We don't have to specify the name of the variable holding the table. And the reason that we don't have to specify is because we already specified it up here that we're returning this particular table with this particular name. So when you're doing a multi-statement table valued function, the return statement can stand alone and it will return whatever table you have generated in this area. So let's put this into our TSQL and test it out. So we'll just scroll down here a little bit. In order for this to work, I need to switch over to our company database. Because our employee table is not in WeAdventure. So we'll execute these pieces to create the function. And now when I want to call the function, I'm going to select all, and we put this function, because it's a table valued function, we put it in the from line. So we have to specify for name type either last or full. So if I specify last, we'll see a list of employee IDs and employee last names only, where if I put in full, we'll see employee IDs and employee first and last names. And you'll notice the structure of the table. We have the column names here, and all the data types will be as we indicated them. Employee ID will be set as the primary key. And we can treat it just as if it were a table. So for example, if I just wanted to select one of the columns, I don't have to select everything. Or I can add a where line. For example, if I want to just have names starting with M, we can apply that as well. So whenever we have a table valued function that we're selecting from, it's just as if you're selecting from any other table. So when we call the function, we call it in the from line, similar to when we call from a table or a view. Once the function exists, we can choose alter if we want to overwrite it with a new definition, or if we want to remove it, we can put it in a drop statement. And the syntax for these is the same as for a scalar function. So there's very much similarities between the two different types of functions. The only real difference is in what type of data it returns. So I hope you enjoyed learning about table valued functions. That's our last topic for the week. At this point, you are able to get about halfway through Lab 3 with this knowledge. And if you have any questions about this or any other topics in the course, feel free to contact me at any time. Have a great day.